So in today's video, I'm going to be visualizing the gradients as the neural network trains. So let me come over here and import axes 3D so I can have a 3D chart. So from MPL toolkits.mplot 3D import axes 3D. So I will come over here and this will turn into projection equals 3D. Um, so now that I have that, let me come over here. So I need to figure out how many layers I have. So I have 5 inputs, 3 outputs, so that's 2 hidden layers. Let me just verify it by, well, okay, let me get rid of all of this for now. I'm not gonna need it. So I will do model equals AI of length of X, length of Y, and then I'm gonna print model, oh wait, no, let me do model.build. Oh, is it build parameters? Yeah, build parameters, and then print the length of model.l. That's the layer. So okay, so I'll do Python 3 gradients.py. So yeah, we're still dealing with the neural network that I coded from scratch. But we're going to be moving on to some new material very soon. So definitely stay tuned for that. Okay, so there's 3 layers. So 5, 4, 3. Okay, good. So in that case, that means I need 3 plots. There's 3 sets of weights. So I already declare it up here. Um, so what I'll have to do is actually pass the plots. So I will do ax equals fig.add. Oh wait, yeah. Let me get rid of ax over here. Um, Let me also get rid of fig up here. I'll just put it down here to make it easier. So then this will be fig. Let me change it to 10 by 5. So fig dot add subplot of 1, 3, I plus 1 for I in range 3. And then I will do model of x, y, and plot, or no, ax I mean. So if I come up here to model, I'm going to add the argument ax. So I will do for ku in enumerate self.axis. Actually, no. I think I could just do it like this. I could do. Oh no, it's to index the plots. So I will. Well, do I want the? Yeah. I want it in this direction. So yeah, I'll call it ku in enumerate self.axis. So then this will end up being ax of k dot cla, ax of k dot plot. Actually, let me test something out. I'll get rid of this file. So test.py import matplotlib dot pyplot as plt from mpl toolkits dot mplot 3d import axes 3d. Let me do z equals 0.3 times numpy dot ones of 3 by 3, and then do fig equals plt dot figure ax equals fig dot add subplot 111 projection equals 3D. So 3D. Let me also import numpy as np, import random as rd. So this will just be rd.random times that, and then ax.plot surface of z, cmap equals jet, and plt.show. Let me go ahead and run python3 test.py. Okay, so I need x and y. Okay, so I'll just come over here, rmrf test.py. That doesn't exist anymore. Okay, so I need to somehow come up with x and y, so I will do pxpy, or rather, let me do mono equals self dot w of u dot shape, and then it's going to be mx my equals numpy dot mesh grid of list range mo, and then list range no, and then over here I could do ax of k dot plot surface of mx my self dot wu cmap equals jet reversed, and then plt dot pause 0.1. Or rather, I'll do it down here. And it's not ax of I, it's ax of k, and then self wu. So down here, I will just do plt dot show. Okay, so let's see what this looks like. So clear that. Oh wait, I don't need to run that again. So Python 3 gradients dot py. Axes has no plot surface. Oh, right, my bad. Projection equals 3D. Yeah, I didn't declare that. Yeah, axis 3D is imported. So I'll run it. Shape mismatch 5 and 6 with 6 and 5. What? Oh, I see. So it has to be transposed, or rather, this will be mx, this will be my. Um, Run it. Okay. Maybe this has to be transposed. Okay, so we can see the gradients changing. But now let's make this more interesting. So I'm going to open a new plot, and now we're going to visualize the gradients testing. So this will be 0, 0, 1. How much do I have epox for? 100. I will do epox. Yeah, I'll keep it at 100. But let me redefine x and y. So that's going to be x equals numpy dot random normal of, let's see, I'll make this 200 by, how many do I have? 6. And then y equals numpy dot random, or rather y could equal numpy array of just like, oh no, I could do random normal again. So random dot random normal of 200 by 3. So 6, 3, 3 layers. Yeah, the dimensions match up. Maybe just random. Yeah, so this will be for ix, iy in zip x and y. So then I'll just train the model as like ix and iy. So now, not that one, Python 3 gradients.py. So let's see this loaded. Tuple cannot be interpreted as an integer. Okay, let me try it again. Random takes one positional argument, two given. Okay, so it doesn't work for random normal, but it works for random. Some formatting issues right there. Could be just how it's coded. Okay, now this is not working. What happened? Okay, so something happened. IX, IY, AX. Oh, maybe this was supposed to be in here. Okay, so open a new terminal, gradients. Okay, they're slowly changing. Okay, now they're starting to change. The plane is getting different. Okay, you know what? Instead of doing it like that, let me just get rid of the 3D plot of it. I'll do it as a contour map because I definitely saw some like good results in that. So get rid of PLT, come up here, get rid of axes 3D, and also before I forget, I have to do these as contour F. So instead of ax.k.plot surface, this is going to be contour F. I'll zip this out here. And just for the video's purpose, let me go ahead and make the gradient actually huge so we can just see the weights training. I'll do it like 1.5. Okay, so now run it. And we have it. So these are the gradients updating as the neural network is training um, on different sorts of data. Yeah, this is fucking cool. Like, it's under the hood how like AIs look at a very micro level of like how they learn. Like this expanding red polyhedron is learning. Like these are the weights being adjusted in the neural network. Um, but yeah, I think um, I think I'll pretty much leave it off here. We got to see the gradients visualized and everything. So yeah, I thank y'all for watching this video. I'm gonna keep coming out with more and more good machine learning content, so stay tuned. And peace out.